Before going further down the lecture slide, let's look at the next few pages of the student guide. There are no lecture slides for them, so you'll need to look at your student guide. The pictures are also in the Astronomy Notes textbook as well. How can you tell just by looking at the moon if it is in a waxing phase or in a waning phase? Well, for observers in the northern hemisphere, there is the fact that the waxing phase has the daylight side on the right, and the waning phase has the daylight side on the left. The three sets of pictures from high above the Earth-Moon system show how this comes about. If we start with the picture in the upper left, we have the typical setup I've used in these lectures and in the textbook, with the sun to the far right of the Earth and Moon. The stick figure observer is raising their right hand, and their left hand is angled down. So we're looking at the back of their head. At the first quarter phase in waxing gibbous orbit positions, the sun is toward the observer's right. One half of the moon is always lit up, but how much of that lit part we can see from the Earth depends on the angle between the sun and moon, as I've already described. Since the sun is toward the observer's right, the lit part of the moon is toward the right. How does this work for the waning phases then, which are lit on the left side? The top right picture shows the waning gibbous and third quarter orbit positions. The sun is toward the right side of the page, so the lit side of the moon is facing right in the picture. Why then are the waning and third quarter phases lit on the left side as we see them from the Earth? Notice the stick figure observer is facing upside down in the picture. The observer is still raising their right hand with the left hand facing down. At the top of the page, the second sentence says, "To help picture what the observer sees from their position on Earth, rotate the picture that the observer looking at the moon is right side up." That's what I did with the lower right picture. The sun is now on the left. The observer is facing right side up, not upside down. The third quarter and waning gibbous phases are lit on the left side facing the sun. Finally, in the lower left corner is a memory aid I use to remember waxing and waning for those of us in the northern hemisphere: beeswax and de wane. The lowercase letter b has the rounded part facing to the right, just like the rounded lit part of the moon during a waxing phase. So, bee wax, beeswax. The lowercase d has the rounded part facing to the left, just like the rounded lit part of the moon during a waning phase. So, de-wane, de-wane. The next couple of pages take you through the four-step process to convert the orrery view from high above the Earth-Moon system to what we'd see on the ground. Remember that the observer is always raising their right hand, so you're looking at the back of their head. Also remember to rotate the Earth-Moon-Sun drawing, so the observer facing the moon will be right side up. These two-dimensional drawings can only do so much in helping you visualize the moon phase we see from its orbit position. Another thing to try is using a white ball lit up by a single light bulb in an otherwise dark room. The light bulb is the sun, the Earth is your head, the observer's location is at your eyes, and the white ball corresponds to the moon. Now, as you move the moon around your head, you'll see the ball go through the set of phases. You should move the ball towards your left, which is counterclockwise. Your head would also spin toward the left counterclockwise. The next 4 pages in the student guide are the Mapping Solar System help slides. They show a powerful technique that you can use for any object in our solar system to see where they would appear in the sky if you know their orbit positions, or go the other way, where they would appear in their orbits if you know their positions on the sky. I'm going to go through the steps in the help slides and then apply them to a couple of scenarios for the moon. This technique has you create a time compass that indicates the direction of noon, sunset, midnight, and sunrise for a given position of the Earth in its orbit relative to the sun. In the first step, find the noon direction. Since the time on our clocks are based on the sun, the noon direction is when your part of the Earth, the observer, is facing the sun. If the sun is to the left of the Earth in your drawing, then the noon direction would be toward the left. If the sun is below the Earth in your drawing on the page, then the noon direction is toward the down direction in your drawing on the page, etc. Noon in the time compass is always toward the sun. For us in the northern hemisphere and north of the tropics, All of the interesting solar system action will be happening in the southern sky, which is why you need to face south. East will be on the left and west will be on the right. East, south, west rotate with you on the Earth. Place your observer at the given time of day on the time compass. Draw the observer raising their right hand and lowering their left hand. You're looking at the back of the observer's head. The Earth spins from west to east counterclockwise, which is why things rise in the east and set in the west. In the third step, the 6 p.m. or sunset direction is 90 degrees from the noon position. If you look at the left picture, the 6 p.m. sunset direction is toward the top of the page. In the right picture, the 6 p.m. sunset direction is toward the right side of the page. The bottom picture of step 3 shows the time compass for 4 different positions of the Earth in its orbit. Noon is always the direction from Earth to the Sun. 6 p.m. is always 90 degrees from the noon in the counterclockwise spin direction from noon. Here are the answers to the question marks in the bottom drawing. The fourth step is to draw the observer's horizon for the given time of day. Because the Earth is so much larger than we are, the local part of Earth looks flat. That's why you draw a straight line perpendicular to the observer. East is toward the left-hand side of the observer, south is the direction the observer's head is pointing, and west is toward the right-hand side of the observer. Notice that east, south, west will rotate with the observer. There are no east, south, west, north directions in space. They are relative to the observer. These drawings show the noon horizon positions. In the top left picture, south at noon is toward the right side of the page. In the top right picture, south at noon is toward the top of the page, etc. If you wanted to show the 6 p.m. sunset horizons, then they would be 90 degrees counterclockwise from the noon ones shown here. The horizon lines spin counterclockwise throughout the day. In the bottom picture, note that the observer is always facing the south direction. South at noon shifts direction on the orbit drawings as the Earth moves around the Sun. Step 5 is actually a repeat of Step 2. Things in the western sky are to the right of the meridian, which is due south. Anything on the west horizon line is setting. Step 6 has the key facts if you're going from orrery, or orbit view, to the ground view. In the bottom picture, the noon direction for the Earth, drawn below the Sun on the page, is toward the top of the page. Therefore, at sunset, the meridian due south direction is toward the left side of the page. The horizon line is drawn perpendicular to the 6 p.m. observer, so the horizon line goes straight up and down. In the orrery view, the Moon and Jupiter are positioned directly to the right of the Earth in the drawing, so at 6 p.m., they would appear in the south direction at the ground view drawing. Saturn is near the horizon line, a little left of it, so the ground view shows Saturn low in the east as it rises. Now we go back to the first lecture slide to apply the steps to a couple of scenarios for the Moon. You're given a picture of the Moon, and you have to tell me what time of day or night it will rise or be highest on the meridian or set. Step 1 is identifying the phase and if it's waxing or waning. This one is a gibbous phase, and since the left side is lit up, you recall de wane. So it is a waning gibbous phase. You can either memorize the table you filled out in the student guide or remember that the waning gibbous phase is in between the full and third quarter phases, or use the mapping solar system technique. I'm going to use the mapping solar system technique. Step 2 is placing the moon phase in the proper place in its orbit. I'm going to draw the Earth-Moon-Sun system with the Sun on the left, since the left side of the Moon is lit up. Step 3 is placing the observer on the Earth so the observer is facing the Moon. That's because the question asked you to find out when the moon phase was up highest in the sky. That's when our part of the Earth is pointed right toward the Moon. There's the standard stick figure with the raised right hand and the lowered left hand. Step 4 is determining the time of day on the time compass for the observer's position. Noon is pointed right toward the Sun. Sunset would be in the straight down direction of this drawing because the Earth spins counterclockwise. Midnight would be your part of the Earth pointed directly away from the Sun, and sunrise would be in the straight up direction of this drawing. The observer is in between midnight and sunrise, 6 a.m. Now for the second scenario. We are given the Earth ground view below for the 4 p.m. sky, and we're asked to place the objects in their orbits in an orrery, or very high up view. We're going to do this for both the Moon and Mars. The Moon phase appears to be a waxing gibbous, and it's rising in the east at 4 p.m. Mars is on the meridian at 4 p.m. Step 1 is drawing the Earth and Sun with the Sun anywhere you want. Here I choose to put the Sun to the right of the Earth. That is, the Sun is on the right side of the drawing. I orient the time compass so the noon direction faces the Sun. At noon, the observer would be pointed directly toward the right side of the drawing where the Sun is, and at sunset, the observer would be pointing straight up in the drawing. In our scenario, the time of day is 4 p.m., so I place my stick figure observer in between the noon and sunset directions, but closer to sunset. The direction the observer is facing is due south direction for 4 p.m. Step 2. Draw the observer's horizon as a straight line that is perpendicular to the observer. The south direction is the direction the observer is facing toward the upper right in this picture. Again, the observer is raising her right hand, and west is on the person's right, and east is on the person's left. Step 3. In the Earth ground, geocentric view, the waxing gibbous moon is rising in the east. So place the moon so it is slightly above the east horizon line. This also makes the angle between the sun and moon between 90 and 180 degrees, as it needs to be for a gibbous phase. In the Earth ground view, Mars is due south. So put Mars directly above the observer stick figure's head in the drawing toward the upper right. Step 4. Now shrink the Moon, Earth, and Mars down, but keep them in their same relative positions as you place them on their orbits in the orrery view.